Great, so I won't take longer. This is our Lightning Talk session. These guys were selected by an open call with like many other applicants. It's always hard really to fulfill just 1 hour with like many applications. So yeah, it's just great to have this pool of projects and what we're calling community, people doing different stuff. And being able to share here with a larger community. So the floor is yours, Javier in Spain, and then we have Ihor from Ukraine, Renu in India, and Richard in Kenya. So really happy with this diversity of voices as well. So the floor is yours, Javier.
Okay.
I'll make you a presenter, and the other ones we can just deactivate the cameras and leave space for Javier.
Okay, thank you. Okay.
You presenter now. Yeah, make presenter. See if you can see the button with like share screen.
Yeah, there I can see it. Let me check this 1 second. Sure. Do you see my presentation in the right way or in the presenter mode?
I think it's all right. I'm seeing it.
All right, perfect. Thank you, thank you. Okay, so I'm Javier Conde, and I'm going to present these tools that we have developed in the context of a European project that is related with enhancing CKAN interoperability with the European data portal through high-quality metadata. I have done this work with my colleagues Andrés and Álvaro, and we are from the Universidad Polytechnic de Madrid, the Polytechnic University of Madrid. So our proposal here, that you can find it in this research article, you have the link in the presentation or the QR, is to develop 2 tools to obtain this interoperability with European data portal. And what we want to do is to make the process of publishing open data in an automatic or semi-automatic way. With AI, we can obtain higher levels of automatization, and with the tools that we have developed and the standards like data.apa, you can do it in a fair way. We are using data.apa 2.1.0, but we are going to move to the new versions of data.apa. It's not very complex to do it, but we have this pending. So just to know that in the next months we will have the new version of data.apa. So first, this is the general architecture that we propose for doing this kind of things. What we have here is data sources. They can be IoT sensors, for example, or whatever you want, an external data source. And we are doing this with, in this case, but this can be done with other technologies, with fiber technology, just to maintain the real time status of the entities that we have. But again, you can do it with any other technology to store your data, or directly to the CKAN data portal in this case. And what we do here is we have implemented in Apache NiFi, that it's a platform for big data processing. So in this case, the solution is thought to be implemented in ecosystems that you have a lot of data, and the speed is also very important. And what we do here is to transform the entities that we have, in this case, with a standard that is the NGS-ILD, but again, you can adapt it to any other standard. But NGS-ILD is a standard for representing entities that it's from. It has been developed in Europe, and I think it's very common in industrial use cases. So from these entities in NGS-ILD, what we do is to transform them and to extract from them the metadata that is going to be published in CKAN. And then in CKAN, what we have done is an extension that implements the data.apa. There were previous versions that implemented data.apa, but when we tried them, we faced some problems of compatibility, so we fixed that. And we also added to this extension an OIEMH server in order to be harvested by data.europa.eu. And OAPI PMHv2 is a protocol that is used for these harvesting things, and is one method that the European Data Portal supports. And I think that it's the best one because it's a standard for doing this kind of thing. So that's what this extension does in terms of the publishing the data. So just going into the detail, this would be the NIFI part in which we are obtaining updates or new entities. And we have here, this is how NIFI works. You have some boxes that you have to configure one time, but this is going to be valid for, in this case, 200 data sources that we have integrated in a open data portal, that then it was integrated by data.europa.eu. So it's like, just like this, is like it's as simple as you can see here. The first box is just for obtaining the updates of the data sources. The second box is the one in which we have a template for the metadata in the data.ap format, and the third box is the one that is in charge of publishing the metadata and also the data, if you want, into the open data portal based on CKAN. If we go into more detail, the configuration is as simple as the one that you see here. You have to include the endpoint of your CKAN host, the port, also the API key, different configurations. So it's quite simple, this processor. And the other one that I think that is the one that is most interesting is the one in which you configure the metadata. So in these processors, we have loaded all the CAT-IP 210 metadata that are integrated into the European Data Portal. And here you can configure them with static values. So they are going to be the same value for the entities. That's good, but it's not very useful if you want to do this in an automatic way. So if you want to use the same configuration for a lot of entities, you have the possibility to implement dynamic values. In this case, for example, what we are going to do is an organization per city. We are integrating data from different cities, so we are making an organization per city. And with this simple configuration, you can extract from the entity, so the data, the metadata, in this case, the city name. And you can do this kind of things in a very simple way. And now that what we are doing is working with GenAI in order to being able to extract more data from the entity itself. Of course, there are going to be some metadata that you don't have in the entity, so you have to complete it manually. But what we want to automatize this in the best way, and the LLMs now they offer these possibilities. That in the past it was very difficult because you have to do a lot of NLP tasks and they were not easy to implement. Okay, so as a use case of this semi-automatic publishing process, what we have done is building different entities in this NDSILD format that we want to publish in a CKAN portal. Each building is going to be a new package with a resource, and the data is going to be stored not in the data portal because it's going to be stored in the Orion Context Broker, that it's a database. But the Open Data Portal is going to have the link into this database in order to have the real-time data updated and without any inconsistency. So as I said, each building is going to belong to a city, and each city is going to have its own organization inside our CKAN portal. And once you have the data, or in this case, the metadata in the CKAN portal, we have implemented this CKAN extension that transforms the CKAN metadata into the dcat-ip 210. And also we have this OI PMHP2 protocol that has been served to data.europa.eu to be integrated in the data portal. And now we are talking with the datos.is in order to integrate the portal that we have done in the project into the Spanish data portal in order to be harvested by first the Spanish and then the European, but we are in the process of doing this. So if we see an example of an entity, of a building in this case, they have these properties, and this is the NDSILD format. And what we are doing with NIFI is to subscribe to any entity that appears on or it's updated in the context of this solution. So if a new building appears or an existing building updates some of its information, this is automatically recorded by Draco, by NIFI, sorry, and NIFI is adapting the metadata in case some metadata needs to be updated, and the same with the data. So the process is the same that we showed before, and here we are adapting we are showing all the configurations of this process in Apache NIFI. It's very simple, and again we are updating the metadata in order to be compliant with the European data portal. And another advantage of this solution, concretely regarding the CKAN extension, is that we can transform the metadata in real time in different versions. So when we update to the CAT-AP3, we are not going to eliminate the CAT-AP2 because this extension what does is to transform in CKAN metadata format into the different DCAT-AP or any other standard that you need if you want to be integrated by, for example, not the European portal, but portal from some government that they have their own extension of the CAT-AP, so you can extend it and you can use your CKAN data portal for different harvesters. That's our point of view. And I mean, instead of generating the CAT-AP and storing the CAT-AP version of the metadata, what we store is the CKAN metadata format, and then we transform when in real time when the harvester asks for the information, in this case through this other protocol, the Uhai v2 protocol. So the use case, and I have a video to show it, is that we have a building, in this case from Madrid, and this NDSILD entity is created. Then we obtain that information through Apache NIFI. The CKAN metadata is generated, and the metadata is stored in the CKAN. And you can also store the data, but in this case, we have not done that. And it appears automatically the organization with the city, in this case, that's Madrid, and you see here another city, Santander, from another test that we made. And also the data set, and also the different resources related with this data set. And this would be the DCAT-AP format from the metadata that we obtain from the extension. We have valid this with this open data portal, that is Yoda, that we want to integrate again in the Spanish one. And what we obtain here, it's an excellent rate in terms of metadata. And we have been the first open data portal in terms of metadata during some years, but now as the standard has evolved, we have to update the DCAT-AP extension. We are going to do it in the next months, as I'm saying. So we expect to obtain the highest quality, but being an excellent in terms of metadata quality by the metadata quality assessment that's made by the European data portal is not very easy. And the good part here is that we are doing things automatically. And in this case, this is for the whole data portal that includes 200 data sets. So with one simple configuration, we have included 200 data sets in automatic way. That's our point here. So just to conclude, I want to show the example in order to see how this works. So we started with an empty CKAN, and now we are starting this template with all the processes that I showed you from Apache 9 that implements this CKAN metadata template that has been adapted for this use case and the extension for publishing in CKAN. And now we have created a building, an entity of a building has appeared, and now another entity of a building. No, sorry, it's just one entity of a building. The first one was a subscription to obtain the updates. And here we see how the building has been created. And here you see in the video, this metadata is in CKAN format. So we are complying with CKAN. And then what we are going to do is to transform this metadata into the data.IP in real time. Now, as I told you, the data is not stored directly in CKAN, it's stored in external database, but we have the endpoint here to obtain the information in real time. So now, we are going to create a new one building. Okay, so now a new organization appeared, in this case for the city of Madrid, with again a data set and a resource with all its metadata that's adapted from these processors. Here are the configurations, and you can update it, for example, for storing not only the metadata but also the data. I think that's what I'm going to show now. Now I'm creating a new building, in this case again from Madrid, so the organization of Madrid has not to be created again. We are going to reuse the same organization, but a new data set in Madrid has to appear. And here you see that it appears a new data set, in this case for this new building in Madrid. And if we enter into the resource, you can see that it has been integrated information directly in the CKAN data portal. So now it's not pointing the external database; it's integrated directly in CKAN. And just to finish, here I'm using the DCAT. I'm obtaining the data.IP metadata, and this metadata is the one that has been harvested by the European data portal. What we have done here is also obtaining using an extension that has been made by the University of Cantabria, that they have implemented a metadata quality assessment that replicates the one from the European data portal, and we obtain the current result of our integration into the European data portal with a very high rate that it's our objective. So thank you all, and again you have here the paper that explains all the process, and you have the links to the tools that we are implementing, and what our objective now is to integrate first in the Spanish data portal, and after that we are integrating AI for extracting more metadata in a more automatic way from the entities and the data source directly. Okay, so that's
great.
all from my side.
Thank you very much, Javier. It was very interesting. I know there are lots of CKAN developers in the room who probably have loved to see you demoing this. And also, like, I really like the link with the data.europa data sets and like the public face of all these things. So thank you very much. As I said before, please, while your speakers are presenting, please leave your questions in the chat so we can address right away, because now we are moving to some other project, and then our minds go together, and then getting back to like some detail that Javier just shared would be hard. So let me just see if there are any comments on the chat. Jonathan saying, thank you so much. I'd love to hear more about your experience in working with data sets, not just metadata. interested in this for socially evaluating data sets building on this. Okay, and Joel say, amazing work, Javier. You should register in the CKAN ecosystem catalog. Okay.
Yeah.
So I'll give you a chance to reply to those, Javier, and then we move to Ihor, our next presenter. You want to comment on those comments on the chat?
Yeah, I agree. We have to integrate into CKAN, yes, ecosystem, and we plan to do this. And
your experience working with data sets, not only metadata. That's it.
We have more experience in metadata, because what we wanted to do here is focus on the metadata part. So in data sets, we are working with the part of extracting the metadata from the data, but I don't have so much experience in that part. We are focused only on the metadata part for the interoperability. And you have my email, so if you have some questions, you can ask me by email, and we can meet in any moment. But sorry, but I have to leave to another thing.
Okay, go ahead. Yeah. Just there's one question, Joe, but I will leave you in contact. That's fine. Cool.
Okay,
I see there was someone raising their hands for some questions, but then they lowered, so that's fine. Let's just go to the other. Javier, thank you very much. You can go now.
I put my email on the chat if you want to talk to me. Bye.
Great. Super.
Thank you.
Great. We are officially very late now, so I thank you, Ihor, and everyone for the patience. But at least I think the conversations are interesting, and people are not leaving the room, so which is a good sign. Ihor, so the floor is yours. Directly from Ukraine, it's great to have you, and we are curious to know what you have to share to us. I'll make you presenter now.
Great. Hi, everyone. Wait a second. I want to share my presentation.
Just check if the button, the button of like share screen is now enabled probably. Go ahead.
Okay. Do you see my presentation?
Yes, I can see it. Yes.
You see it, right? Okay. So first, thank you for having me and for organizing this event. My speech will be, in my presentation, will be less technical. However, of course, all the tools I will share with you are technical, but still my key message about AI and open data is about practical use and having value out of the data. So
it's like just to confirm, like your screen says click to exit. No, now we see the slides, yeah, because before it was like click to exit full screen.
I will.
So we can see the slide, yeah.
Do you see one slide, the first one?
No, it says click to exit full screen. Now we can see.
Let me just click once again. Okay, how I share my screen.
Okay.
I will share the full screen of mine.
That's fine.
Do you see right now my full screen?
Yeah, now we see it. I think it's all right.
Cool.
Go ahead.
So once again, I've been a part. If anything happens to my presentation, please tell me. So I've been a part of open data ecosystem for many years, and as a lawyer with a legal background leading policy team, I was more about advocating for opening data sets, not about extracting value out of it directly. And I think that the case of transformation of me, my teams, and what I do and what I share with you, it shows where the intersection of open data and AI actually moves. So before AI coming into form of LLMs, there was a huge issue with the open data. So first, the data was there, it was available, and we worked hard to make it available. But actually there was a really big bottleneck. It was a technical capacity to work with data. So we don't open some data just for it to be published in that or other manner. We try to open it so that we can extract value from it for public good. And given that technical capacity to work with data is quite expensive and narrow, it was really a bottleneck for the value. And what we've seen for many years that the key solutions in open data market was either grant funded or market driven, and you need to have a strong business case to create something with data, because it costs. And what is right now going on, and I will share with you the examples from my work, that AI actually lowered the cost of turning data into usable tools. And right now, people like me who previously were advocating going into courts to open the key data sets, and I'm happy that some of the colleagues of mine are here at the call, for instance, Nadia Babinska, who asked the question in the previous Q&A session. She was the plaintiff winning the court against Ministry of Justice with the business register. And Ministry of Justice opened the key data set for the business, the whole business register. But the point is that neither me, who participated in this, nor Nadia, personally, we couldn't actually directly use this data. So this right now changed the field. AI changed the field. And I will share with you the AI stack on the example of justice data, which I've been building as a consultant to the biggest Ukrainian think tank. And it comprises 3 layers. First, automated monitoring. Second, the AI chat with the case law in a natural language, in your language. So not just natural language, but your language. And the third case is pattern detection. So these cases will show how we turn just the accessible data to really the use cases that extract value out of it. So the first use case is creating an automated monitoring on a specific court judgments. We created the Telegram channels about the anti-corruption cases and about the adult content cases. So basically the workflow is pretty simple. We take the open data about the new verdicts, we summarize it, and we post it automatically on Telegram. This is a completely automated system. But it changes drastically how the legal professionals, journalists could get access to the information, because you have so many court decisions and court rulings, and you can't just go and read all of it. But you can have a monitoring system on a specific matter that is interesting for you, for your job, for your editorial, and so on. And actually, the tool that we've created is used by MPs, by ministries, by journalists, and some cases have a more than 1 million reach. So this is like a putting a motion detector in some big archive that signals you when something interesting happens specifically to you. This is the first layer. The second layer I want to share with you is a chat about basically court decisions about open data access. So we all know that it's not very simple quite often to get the data you want, and there are disputes about access to open data. So what we've created a natural language interface using the data set made out of the decisions from courts. And right now, everyone could just ask in their natural language the questions about the court practice, about the potential of their dispute with the authority, or maybe how to avoid the mistakes when filing the request or filing the court case. So basically, this is used by journalists, by activists, by civil society. It's free. It's based on AI. And basically what we've done, we've took all this wall of text and created the doorway out of it. And I will share the links to everyone I share with you in the chat. So now I want to share with you the last but not the least solution, where we created a layer, not just summarizing or chatting about the documents, but actually when AI helps to hold accountable the whole complex justice system. This is the case that could be scaled and replicated. So what we've done, we've took hundreds of verdicts, and with AI, we analyzed them to find different inconsistencies. And what we found with AI using court open data, that every 10th court verdict actually quoted the repealed law. And 27% of court decisions, they mentioned the convention that Ukraine never ratified. Why this case is so important? Because we used to hear a lot about hallucinations, right? and mainly the discussion is that AI hallucinates. But the truth is that classical institutions hallucinate too. And the cost of an analysis that could improve the institutional work at a scale before AI was just not affordable, you know, for civil society, for activists, because you need like the higher courts, they have hundreds of people looking for inconsistencies in court decisions. But right now with AI, you could scale this at a tiny fraction of cost. So in this case, AI is turned into infrastructure layer, improving how all the epistemic infrastructure of the institutions might work. So what these three layers and this infrastructure about justice data shows us, and this is only a tiny fraction of cases that I've been involved into, is that before we had the open data accessible and we worked for it, but we had this really, really narrow bottleneck of technical capacity. Unfortunately, this bottleneck was touching all the fields in the economy before, but right now AI really changes this. But what this meant, that open data, even when it was published, you know, it wasn't necessarily used to the edge of its potential. So the potential of open data is so enormous and the usage was relatively so small. But right now, AI really removes this barrier. So right now, nearly everyone with close to zero cost could unlock the value of open data and build a solution based on it. Because the point of open data is not just to publish it or to make it accessible, but really to bring the value to people. And accessibility doesn't matter that there is file, you know, when people like me before having this change with AI just saw this file, they said, okay, so what am I going to do with it? I need some team, I need some resources, I need some extra money. But right now AI removes this barrier. So what I'm building right now, and basically this changed my career, this changed how the teams I worked with operate. We right now not only advocate for more and more open data, we build more solutions and extra layers for better governance, for better transparency, accountability of institutions. So I've shown you the pilots that could be replicated easily into your countries, into your use cases, into your fields. So if you're interested in scaling this, please feel free to reach me. I'm open to institutional collaborations. And these three cases, they touch the justice specifically, but this is only one field. And the same approaches could be applied to policy making legislation. And just on top of it, we're speaking about future. I believe that from what I've shared, we see clearly that the next step is that we have actually the new value pipeline from the open data. We publish it, we create case, and we get benefit for the society from it. And this really brings a new quality of our work and the value that we bring as open data community. The society will increase like dramatically. So that's it. I'll share the links to the solutions in the chat.
Can you hear me? Yes. That's really great, Ihor, and thank you for this great insight you gave us, like the institutional hallucination. I was just hallucinating with this term. It was really, really interesting. Thank you very much. Before going to Renu, you can keep your camera, Renu. There are a few comments and questions in the chat. I'll just give you a chance to reply in the 2 minutes we have left for you. Zane is asking, what format do the court documents get published in? If they are machine readable or not? If they are like a mountain of PDFs and words processing documents, which is very similar to the problem they have in the US. You know, this I think this is common everywhere. If you can comment on this,
yeah,
then I can.
It's not PDFs. Yeah, it's not PDFs. It's machine readable format. You could make a bulk download, and for some solutions like Telegram channels, for instance, we just take from partners API data. So some organizations in Ukraine, they take this big open data files and they create API based on it, or they have the direct approach and they pay for the API. So there are different ways for different tools. For instance, for this hallucinations tracking, we took just the open data and we took the precise court rulings we needed, and then we used this specific narrow file that we created out of the bigger file. But for instance, for the Telegram channel, so that we do not create our own API, we just took the partners API for free, because we have a number of solutions in Ukraine based on this open data from the government, so that it's just more convenient to take from them from time to time.
Great, clear. Thank you. And also Jen from Sweden commented there's like this RSS feed with all the documents, and then you can see with keywords and so on. Like, just you voice this to the session if you want to comment on this.
Yeah, I want to comment that Jen's comment is something really resonated with me and with what I've been doing. So this summary and tracking, I just want to highlight that what Jen basically mentions, that there are different feeds, API, open data, website updates, and so on. Before AI, we couldn't actually track this in a consistent manner because it was so resourceful. We needed to invest so much. And right now, the AI transforms how we can monitor something. And basically, this transforms completely the transparency of institutions and their accountability, because we don't need a staff of 10 people to track specifically the narrow case that we want to know about. We can set up the system once and address it for ourselves or for 100 of journalists, and they will track these court decisions. It is a silent channel, not a big one, you know, but when there are like 100 journalists and they see the case, then they spread it across all the nation. And this is the new approach to tools that we are applying, and I try to build basically, and I show.
That's great. Thank you very, very much. I'm sorry for being late again, for you and for the entire room, and for Renu especially. And yeah, now we are going over to Renu so she can present Semantic Climate, which is a long-time partner of us at CKAN. She's also a Frictionless Data Fellow this year. So it's great to have you here, Renu. And I'm really sorry that you need to go over your evening. And that's the problem with global things, right? Like this is very early for me in Latin America, and it was for some other panelists as well. We're making the best to bring this open data community together. So thank you very much. The floor is yours.
Thank you, Lucas, for the introduction. So can I have the option of sharing the screen?
I'm giving you the permission right now. Just looking at the name, Renu.
Yes.
Take presenter.
Okay.
Can you see the button? Yes.
Yes, you can see the button. So I will share my whole screen. Your entire screen. Okay. Okay. Now, is it my screen is visible?
Yes.
Okay, fine. Thank you. So, hello everyone. I am Renu Kumari from Semantic Climate India. And to begin with, before I begin to my presentation, so first of all, I'd like to thank you all the organizers and the open data team for giving me the opportunity to present the Semantic Climate vision and the tools we are developing and how we are working at the Semantic Climate. So, Semantic Climate is a 6-year-old organization where the team of interns, either online or offline, they work by creating the tools, and then they are using it for the open data and the climate knowledge. So we have the interns across the world, and sometimes from the India, all the parts of the country, we are having the interns. We organize the workshops to disseminate the knowledge and hackathons, and also the school events in the form of games. We are distributing the climate knowledge. And also, we are basically, the aim is to create the frictionless data from the friction document. So why we are working on this climate open data or any kind of open data that is available to all of us. So the challenges here, it is we have a lot of publications and reports coming every day, and they are mainly occurring in the PDF formats. And the main reason for the PDF is frictionless, is machine readable. No, it is not machine readable, and it is also not the structured format. So and it is also not accessible and easy to navigate through these documents, like the climate reports and the research articles. They're all in the PDFs. So semantic climate vision has to change this semantic unstructured data into the semantic form using the semantic toolkits, and so that they can be accessible to both the humans and the machines, and they are all readable. And we are have the goal to help the scientists, policymakers, communities across the world to work on the climate knowledge in a better way. And we are also creating the youth knowledge champions across the world, and they are coming and then gaining the knowledge about the technology and the tools. So for this year, we are having the interns that are working on the different chapters of the climate reports coming from the IPCC. So they have been assigned the different chapters, and they are they are converting this semi-structured climate report into the semantic form, and also into the frictionless document using the semantic tool Emulate. So the overview of my presentation is, if we have the climate reports or any scientific literature in the form of PDF that is not like machine readable and human accessible, so we take those reports and convert into the semantic forms, and then try to extract the information. The first level of information we are extracting is the key terms or important terms, key phrases present in those reports. So so that we can enrich those key terms with the information from the authentic resources. So and we call it as an encyclopedia because it has the figures and the descriptions from the Wikimedia. And then we create the knowledge graph so that we can see what the terms are related to which terms, like how they are linked to the, so that the school students or any high schoolers can understand, like in this figure you can see climate change is related to many terms. So we can easily visualize the context of our chapter or reports. So the workflow we are using is like if you have a query of any term, like I wanted to ask a question about the ocean heat or any climate related or any query for my research. So we give those queries to the Pygate paper tool that is like developed by the Ayushgar, who is also the intern at Semantic Climate. So this Pygate paper tool, what that does is retrieves or get the research articles from the open data repositories like the EuroPMC, OpenLX, and Readily. So it give the research articles in a very less time. If you give the 100, then it gives the 100 articles in a very less time. So we get the research articles from the open access repositories using the Pygate paper tools, and then create those reports or into the semantic structure format, and then we use the tool like txt2 phrases to extract the important key phrases from those tools. So, and after extracting the informations in the form of terms and the key phrases, we use the encyclopedia system to create encyclopedia, enriching information from the Wikimedia, and we visualize in the form of knowledge graph. So the resources we are using is, first level of resources is the climate open data, and they are published from the different organizations. Here I am taking the example of the IPCC report, that is AR6WG3 chapter 14, international cooperation. So where many terms are present in the whole report, so sometimes we don't understand about those reports, so we have to go to the Google and everywhere, so search for the each and every term individually. But after creating the encyclopedia, we can connect those encyclopedia to these reports, so and we can see the meaning of the words itself here. So here I have taken an example of the Kyoto Protocol. So sometimes we don't understand the meaning of these Kyoto Protocols at so we wanted to create the encyclopedia for this whole chapter. So you are using firstly the tool txt2 phrases to extract the key phrases present in those reports or chapters or research articles. So here I have given the example of the in the table, like where I've used the txt2 phrases to extract the information. So it has given the many, like I have given the cutoff of 500. So out of those, I'm showing the few words so that we can get the better understanding. Like here, Paris Agreement has come 306 times in that report, and the Kyoto Protocol is mentioned 69 times. So it means it gives the glimpse of the report that it is related to the international relations protocols and working on the climate change. So after that, what we do with this list is give to the encyclopedia system, and CSV, the term present is the CSV or the TXT file. It will given to the encyclopedia system, and it will create the encyclopedia. And here the example I'm taking is the Kyoto Protocol. I'm showing just a part of the encyclopedia because this is a long, I've given the 500 terms, and then it has created long encyclopedia for me. And then here the Kyoto Protocol, like if I wanted to know about the Kyoto Protocol, then it gives the descriptions from the Wikipedia, and also the images we are getting to better understand what the term is, and also we are getting the Wikidata ID for connecting to the knowledge graph. So we are also visualizing the results in the form of knowledge graph. Like here I have taken the first few words to create the knowledge graph, like climate change. Climate is connected to the SDGs and the sustainable goals and the climate mitigations and Paris Agreement. So anyone can understand that like this chapter is discussing about all this terminology, and we can like browse this whole knowledge graph and search the term in this knowledge graph. So nodes are the terms we have given to the creating the encyclopedia, and essays are the links present in the Wikipedia description. So this network can be increased to the many terms. We can increase to the 1,000 primary terms to create the big network and understand the concept better way. So to summarize my talk, that like we are creating semantic documents from the semi-structured documents using semantic tools, and then extracting key phrases from those semantic documents and feeding into the encyclopedias and having information from the Wikimedia. And then we are linking to the open data graphs. So this whole methodology is generic. It can be applied not only to the climate, but also to the any research area or any document offering in the PDF or HTML and everything. And it is the good thing is that it is not contaminated by the AI hallucinations, and we are using the trustworthy resources, and our technology can be used in an automatic mode by non-experts also, like the climate school students. So we have the collaborations in the sponsor across the world. Like I'm working in the BRIC and IPGR, so the interns come for the 6 months and they work on the IPCC reports and UNFCCC reports, and they make it semantic and extract the knowledge from there. And we also have the collaboration from the TIB Hanover, and they are working on the ontology creations in the knowledge graph. We have the OKFN, and where we are working on the AI chatbot, and CoData, where we are working on the tool OT-Virare, where we are working on analyzing the annual reports of the institute and extracting information from the institute and assessing their research, and we apply the multilingual concept to that. And the Climate Academy, we are trying to create the semantic encyclopedia for the learning purpose. So these are our resources from the Semantic Climate, and they are the software we are using, developed by the Semantic Climate interns along with the mentors. So with this, I'd like to say thank you to the all organizing team and our Semantic Climate team. Thank you all.
So again, just time to activate my camera. Thank you very much, Renu. It was amazing to listen to you again. We have a question in the chat by Xenia. How do you take care that your system is always up to date? I think it refers to your talk, right, Renu? Someone, Charles saying excellent presentation. Steve, do you want to take Xenia's question?
Okay, what the questions? I have not like.
How do you take care that your system is always up to date? I don't know exactly what you refer to. What system is that?
So which part of how do you take care that your system is always up to date? Like which part?
Yeah. Xenia, if you can clarify.
If I can come in just to say that this is it's a prototype, and it's primarily at the moment building proof of concepts, right? So the IPCC is static. So, you know, that's fine. And we keep adding things to the software. So it's, at the moment, it's an analysis of a static resource. The same with the United Nations FCCC, right? Obviously, the software gets updated. When it comes to the literature, we have a tool that anybody can use to build their own scoping review of the literature. Does that answer the question?
I think so, and I think also Xenia is referring to like new reports that are always being published and how to make like the database.
Yes, so I think the tool, the tool is capable of doing that. Like the PyKit paper, we are giving the time frame also, and it is taking the recent public reports and everything. So it is taking care of the times also.
Nice, thank you so much, you and everyone who are staying with us, even if we are over time. We have one more presentation today. It's by Richard Muraya. If you can activate your camera. Renu, thank you very much.
And thank you, everyone. Thank you.
And just a quick explanation before we go to Richard. Again, he's now activating his camera. We had one more talk planned, Scientica, but she has actually not been able to join us because she should be traveling. She sent me a recording of her intervention, so I'll put the link in the chat so you guys can access. But then, as we are late, we are just cutting like the broadcasting of this presentation live. Okay. So let's go now to Richard Muraya in Kenya from the Demography project. Looking forward to your presentation, Richard. Welcome. I'm making you presenter now.
Yes, thank you very much, Lucas, and good afternoon, everyone from Kenya. My name is Richard Muraya. I'm the Executive Director of the Demography project. It's a small community-based organization that does environmental monitoring for the sake of the environment as well as for the people whom we serve. Allow me to share my screen with you to make the presentation. So I hope you can see my screen clearly. Okay. So
yes,
my presentation. Yes. Thank you. So my presentation is on our open data dashboard, which relies on citizen science, as Rem has just presented. And again, the reason why we are doing this is because we want to merge the concept of people and planet with our audience or the communities we serve. Our project for this round is called Uhai, and Uhai means life in Kiswahili, which I'll elaborate through my presentation. So, like I mentioned, we are a small community-based organization which undertakes environmental monitoring through civic technology, citizen science, as well as grassroots journalism for sustainable natural resource management. So basically what we do is that we empower communities with both data and tools for them to make informed decisions regarding the environment and their role in conserving natural resources. We are based in a small village in Kenya, in a Kihumo village. This is where I am currently. And this is where both our organization as well as our host community lives in. So for the programs we undertake, these are 4 in number. The first one is called Mae Makwa, which focuses on freshwater resource responsibility. Mae Makwa means my water in our indigenous Kikuyu language. The second program we run is called Infrastructure, which is a combination of 2 words, infrastructure and tracker, where we do majority of our environmental monitoring work. Number 3 is called Bungeni, which is Swahili for in parliament, where we do parliamentary monitoring for our local assembly, again, so that you can be able to ensure that communities have a role and a voice in legislative and policy formulation processes. The last one is called Mtandao, which is Kiswahili for community networks. And this is basically on enhancing digital literacy as well as security for community groups like ours. So I'll go straight into our presentation, which again, like I mentioned, is called Uhai. It's our open data dashboard, which more or less is the final product from all the work we're undertaking on citizen-generated data, as well as accessing open government data with regards to the environment. And it has a lot of data sets that we've been working on over the past 3 years, most of which is still under review and data cleanup processes. So primarily, as you can see from your screen, we don't just look at one particular domain, either water quality monitoring or air quality monitoring. It's comprehensively covering the role of the individual as well as the household in our position and how we can conserve our natural resources. So the available data sets, like I mentioned, we are focusing primarily on the first two programs, that is Infrastructure and Maemakwa, where we are getting data from public infrastructure monitoring, including the cost of this public infrastructure, getting the environmental impact assessment reports, as well as all various indicators to show just how public infrastructure or service delivery is being undertaken at a community level. Number two is on seismic or geological monitoring. The reason is most of the communities we serve, including our own, have their own stone quarries where stones are mined for construction purposes. And again, there's a lot of blasting or disruption of the natural environment. So we undertake this analysis through sensors we are installing across the communities we serve. Again, so that we have all this data readily available for any remedial action, both by the communities or other stakeholders. We also do noise and air quality monitoring, again using readily accessible consumer grade electronics, again so that you can generate data sets and showcase now how this impacts not just human health but also the environment around us. Lastly is also meteorological data from the stations that we've installed across the communities we are working with. For Maemakwa, it's primarily on freshwater resource availability, both tap water as well as freshwater resources around the communities, by undertaking consumption tests, doing water quality tests, as well as engaging stakeholders on how to improve service delivery. Other components that are addressed within our dashboard include environmental journalism and grassroots storytelling. We want to empower communities or individuals within at the grassroots level to write stories that perhaps may not get audience from mainstream media. So this again will enable them also so that you can be able to see stories or the lived experience from people under the risk of perhaps climate action, amongst other environmental degradation issues. Also, we are generating a compendium of all local and national policies and regulations surrounding these key resources, as well as also integrating global agreements or regulations that have been passed. Lastly, since we have a commitment towards environmental education, we are also integrating age-appropriate MOOCs, just so that we can have learners from an early level all the way to university level to undertake courses for them to understand their role in environmental education. So in practice, why Uhai? Like I mentioned, we are strengthening citizen-generated data as well as integrating available government data on environment and making it available for all. The reason is the Global South has a key challenge with regards to inadequate data regarding our environment, which is hampering climate action from this regional level. So basically, we are trying to plug in these data gaps through, again, building human interest in open data systems, grassroots storytelling, as well as just having communities have a say with regards to how the environment can be conserved or how climate action can be fully realized from a local level. The data collection process is very tedious. This is just a summary, or the written summary of how this goes about, because a lot of this involves direct fieldwork within the communities we serve. And we are very grateful to the Open Knowledge Foundation Network that we've been able to integrate the Open Data Editor in synthesizing or cleaning up this data. I need to mention that for every hour that we undertake our fieldwork, generates about 50,000 different data points on various issues that I'll show you just shortly. So all this needs to be cleaned up, and the ODE has been very instrumental in enabling us clean up this data and making it available. So the actual data collection process involves a lot of walking, a lot of it. Some of our volunteers walk up to 30 kilometers in a day, just so that we can have enough data sets to make sense of the work that you're doing. So most of this happens within urban or peri-urban regions around, not just our capital city, Nairobi, but other municipalities and cities within the country. So we undertake air quality monitoring using portable air quality monitors, getting this data, extracting it from the devices, and again, cleaning it up, making it available for visualization processes. Some of the data that we also do, we also collect include multimedia data, so that you can have some immersive, first-hand look at how life is, not just during the fieldwork process, but also understand the sources of the pollution or which hotspots are to be avoided. So basically, we are trying to give you a first-hand view and see it at a pedestrian level, how this is undertaken. Number two, we also install air quality monitors donated by various stakeholders that we are working with, again, so that you can plug in data gaps with regards to air quality at a domestic level. We actually have about 55 air quality monitors, which should be installed in the course of this year across the country, which will make our network the second largest in Eastern Africa. And this primarily will be focusing on schools as well as other community facilities to make sure that we plug in the data gaps that perhaps are not even visible from a local level. We also do indoor air quality monitoring and giving remedial measures to households, especially women-led households, on mitigating excessive exposure to particulate matter from cooking activities in enclosed spaces. Most households in Kenya still use firewood, charcoal, and other biomass for cooking and energy sources. So basically, we are trying to empower them with data for them to understand or reduce their impacts on human health. Kenya is notorious for a very chaotic public transport system. So our public transport buses are very loud, have vulgar music. So basically, we have a lot of challenges, especially from the elderly and the youth, children, who maybe have adverse effects from excessive exposure to noise pollution. So basically, we also collect or we monitor the noise pollution from these buses. Again, share this data with the owners of these public transport buses, due to the weird nature of our public transport system. So then they can be able to understand that this excessive noise pollution is harming long-term human health, and again, remedial measures, reducing the volume of these very loud transport systems. Also, like I mentioned, we also do meteorological analysis. So we install weather stations, especially amongst agricultural communities, so they can have real-time data, especially on rainfall, wind patterns, amongst other indicators, for again remedial measures against adverse effects of climate change, and also to inform issues like planting seasons, as well as how basically they can be able to adapt to the changing climatic patterns. Like I mentioned, seismic monitoring, a number of queries have emerged around the communities we serve. So we also collect this data, and we are currently trying to integrate it with our website so that we can be able to have all this data in real time on display for the communities as well as other stakeholders. Still on water, we install the water consumption sensors, which monitor the level of water within water tanks. The reason is we need to also have data sets on water consumption from a domestic level. We do not want to integrate this broadly into our dashboard because this is fixed within at a household level. But again, still for the households we serve, they still have access to this data that they can be able to see water consumption patterns, as well as see how they can be able to reduce excessive water consumption at a domestic level. Like I mentioned, we also do water quality testing. So all these data sets, we are collecting them and integrating them within our data dashboard. So now the analysis process becomes quite tedious because, like you've seen, there are so many devices that you're using, most from various manufacturers. So essentially what we have done is that we've created a Windows software app that you can be able to integrate all these various data sets, whether it be air quality data, whether it be basic GPS data from a smartwatch, from your smartphone, all this data, integrating it into one comprehensive Excel workbook that again can be used to be ingested within our dashboard so that you can have very clear data and all these indicators showing essentially or communicating what we would want the public to know regarding air quality, whether it's noise pollution, water quality, amongst all these other data sets. So like I mentioned, for every hour we undertake our fieldwork, it generates about 50,000 different data points, and all these have to be integrated within our dashboard. So now, once we do all that analysis, we now upload this on our dashboard, which is currently under development. So once you check, if you check through the link that I have shared on the chat box, you can be able to see the various indicators or the different domains on environmental data that you can click and see how this is being undertaken or the results of this work that you are doing. Like I mentioned, we have an excessive trove of data over the past 3 years that we are still cleaning up, trying to upload it on our dashboard. So this is still work in progress. But as we work with the development partners that you can see on your screen, then we can be able to have long-term impact with regards to how citizen-generated data can be used to inform policy and action from a ground level. Before I end my presentation, perhaps just to show you how this is being undertaken. This is a live view of the dashboard. Perhaps if I could focus on air quality, since that is the one which is best available. We monitor air quality, especially even during community events such as marathons or other community activities, so that you can also showcase the level of exposure to air pollution or noise pollution by ordinary pedestrians. So as you can see from your screen, we had one event that we did on Valentine's Day this year. And from this data, as you can see, once all the analysis has been done, the dashboard generates a clear summary of everything or all the indicators that have been generated, whether it's the air pollution, the different indicators, PM2.5, PM1, PM10, the particulate matter, even issues like even ambient, the temperature, humidity, elevation, all these are being integrated in this, and also to give a better perspective on environmental data, so that we don't just see ordinary citizens as consumers of this data, but generators of this data. And all this is for positive outcomes for both people and planet. Thank you very much. That has been my presentation. Again, thank you very much to the Open Knowledge Foundation Network for this opportunity. On your screen, our contacts, and I'm available for discussions on how to scale this initiative. Thank you very much.
Thank you, Richard. Yeah, it's always great to listen to you and to see that this is taking shape. We didn't have these dashboards a few months ago, so it's really good to see it, like the visualization and so on. And Richard was talking about data cleaning and data quality, which is something that sometimes we forget when we talk about AI, the future of open data, and all these like more cutting edge buzzwords. And this is very good to see you defending data quality in this conference. Any questions for Richard in the chat? I would say we have like 1 minute for that, because in 30 minutes we start the afternoon for Europe part of the program. Jonathan, let's see. Would love to hear more about how you approach integration with multiple data sets from different sources devices. Okay, Richard, over to you, and then we finish. I would ask you to go brief if you can. 1 minute, thanks.
Yes, thank you very much. Again, at the integration, we try our best to ensure that one, all our devices are calibrated and giving accurate data. So we work closely with various standard bodies locally to make sure that the data is accurate, especially for the air quality and noise monitors. Then now for all these data that we generate from these different devices, we extract it in Excel format. So once we get it, then we ingest it within the software, the custom software that we've been developing, that again collects all these different data sets that are being collected by different devices. And by ensuring that our anchor is the timestamp, a specific time at a second level, to make sure that all this data is accurate from each device. So now from that point, now it does the cleanup for us, it does the analysis for us, summarizes all this data from per second level to per minute level, so that again you have accurate readings, especially on noise, because the data is very much, it changes frequently. So once that is done, now we extract the data from our software, ingest it again into ODE to identify any gaps or any discrepancies within the Excel data that has been generated. Then now once that is done, we do a final analysis internally to make sure that, again, trying to focus, reduce personal identifiable data, whether it's even as simple as having someone's photo taken as we walk or do our fieldwork activities. Then once that is done, now we ingest it into our dashboard. Then now all that data is available for the public to see. Thank you.
Thank you so much. Great, thank you.
Great, Richard. Jonathan, Charles just asked your question, so I could ask you to use the chat to answer. We are now breaking a little bit. We are all tired, actually, a little bit. So let's take a 20 minutes refresh before we start our next session, which will be, thank you, Richard. I just saw you deactivate your camera. The next session will be great, will be remarkable. There are like big names in the room, a 2-hour roundtable where we'll see what's happening with CKAN, what happened in the last 20 years. That's the start of the celebrations for the 20th anniversary of CKAN, and also how it's shaping the future of open data, especially with AI integrations. It's a mix of demos with reflections. It will be really good. We are really looking forward to it, but we need to take 15-20 minutes. I'll leave this room open, so please do not disconnect and do not log off. And we will get back here in about 20 minutes, I would say. Okay, thank you very much for being with us this entire morning or afternoon, depends where you are. And we'll be back in just a few minutes. Thank you very much.